still live? I don't know if I'm live. I lost internet briefly. Hello? Hello? Okay, I think I'm live. Sorry about that. I don't know how it looked when I lost my internet. Okay. I don't know how this is working here. I don't know if I should restart the stream. Because I was monitoring it on... You know what? Yeah, you know, I think I'll keep going. Where did this end? Hold on. Okay. Bear with me here, folks. Okay. So what we'll do... Looks like it ended right...
The rules go top.
Right about here. So I can fix the fix all the like the thumbnail and all that stuff, but well, that's frustrating. Sorry about that. I think it can tend to kind of glitch out at like 2 in the morning, which it is. It's about 2:12 right now. Now there's another stream on the channel. All right. Well, let's press on. And yeah, I'll fix all that later. Excuse me. Goodness me. All right, here we go.
Top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables, but the one thing you've kind of also, maybe you noticed it as we go by, is we have different kinds of data. We call it type. Is this of type integer? Is this of type floating point number? Is it of type? Has usually at least one slide about this stuff. So like I said, the rules go top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables, but the one thing you've kind of also, maybe you noticed it as we go by, is we have different kinds of data. We call it type. Is this of type integer? Is this of type floating point number? Is it of type string? what is going on here. And Python is pretty smart about various kinds of types of data. And so, we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate two strings. This is hello blank plus there. And plus looks here, says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those two things together so it becomes another string that gets assigned into E, and it's hello space there. The plus doesn't add the space. I added the space by putting it right there. And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us in trouble. So here we have EEE, which is hello there because we've concatenated these two strings together. And now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I've become confused. So your program stops running and you say, here's where I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but you read carefully and you don't get too stuck on too much stuff. Line 1, that tells us something. In module type error, can't convert int object to str implicitly. So that's an integer right there, and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So there turns out that there is, inside Python, a built-in function called type, T-Y-P-E. So we can pass into type. So the syntax is calling a built-in function named type, parenthesis is the parameter that we're passing to it. We're saying, hey, hello, tell me something about the type of the variable EEEE. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking Python through the type function what the type of either a variable or a constant is. And there are even several types of numbers, and we'll even see Booleans and others later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1. And what's the type of 1.0. You can also use a set of built-in functions like float and int to convert from one to another. And so this basically says, I want to convert, oops, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before it can finish the plus, it turns this into a 99.0. The difference between 99 as an integer and 99.0 is that it's a floating point number. And that actually turns this computation, as it looks to the left and looks to the right, it says, oh, I've got a floating point number on one side and an integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has a 42, also an integer, and then give me back a floating point. So that'll be 42.0. Pass that into F, we print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0. Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. This is a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. And this, 10 over 2 could be 5, but 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all, it truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point.
I'm sorry. And I got to back this up a little bit. I need to listen to it again. So 9.2 or 9 divided by 2 will give you 4.5.
Definition to division in Python 3 is it always produces a floating point result. Right. And that Python 3, 0. Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. This is a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable, and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. Okay. And this, 10 over 2 could be 5, but 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all, it truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert into string, so that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in.
Wait,
so it says,
why is it a string?
We say, what is the type of the floating point? But you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer.
Oh,
it is
quotes.
A 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert into string, So that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now add 1 to it and get 124. And
so I val equals oh. Okay, so this just makes sval an integer. Then it asks what ival is, and it says an integer. It says print ival, which is now an integer, plus 1. So it's 1, 2, 3 plus 1, which is 1, 2, 4.
so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're going to end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters, so that's going to cause this to fail. Another thing that we're going to do with variables is, just like the print function takes something, a list of things, in this case, a string, comma, a variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before output. Input is a built-in function, and we pass to it a prompt, a string of text that's going to be printed out for the user, and then it stops and waits. So it says, who are you? And then right here it just sits, waiting for us to type something. So we type blah, 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 and then hit the enter key. Right? We hit the enter key, and then this text ends up in this variable. So this is an assignment statement that Chuck is the result of the input call, gets copied into the NAM variable. So let's do that again. It's evaluating an assignment statement. Remember, it's kind of this way, or you can think of it as just do this right side first. It writes this out, writes that out, then it waits, wait, until we hit the enter, and takes this Chuck, and that becomes the result of this input, which is then assigned into NAM. Now then we go sequentially to the next line. It prints out welcome, comma, contents of the variable NAM. Now this one, this comma here, actually does put the space in here automatically. So it says welcome space Chuck. So it pulls there's no space in Chuck, just the CHUCK. And so print can take more than one thing separated by commas. As a matter of fact, print can have, a whole bunch. Oops, come back. Print can have comma, 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 parentheses, as many as you like. Everything you've seen up to now is kind of one thing in the print, but that doesn't mean that print only can do one thing. So I've talked about variables, we talked about constants, we've talked about input, we've talked about output, and now it is time to write our first meaningful program. And so this program has to do with those of you who have traveled internationally. If you traveled to the United States and you traveled outside the United States, you notice that there is an elevator convention that is different inside the United States. In the United States, the walk in the ground floor in the elevator, that's 1. And if you walk in the ground floor in Europe or many other places in the world, then the elevator is 0. So we have written a small app that we're going to put on the App Store and get wealthy with called Elevator Floor Conversion App. And it's going to ask us, we're in Europe and we're lost, and you say, well, what floor would this be if I was in the United States of America? And so we have to read the floor that we are at in Europe, and then we're going to convert it to a US floor, and then we're going to print it out. This is very silly, but it is a pure essential program that has input, does some kind of task on that input, and then produces some output, which is useful for some value of useful. Okay? So let's take a look at how we combine everything that we've learned in this lecture: input, processing, and output. It's a 3-line program, but it's sort of the beginning of something that programs do. Okay, you're going to do lots of programs that do this. So here we go. Program starts. we do the input, side effect, it prints out this and then waits. We type in 0, that comes back here, and the 0, which is a string. Input gives you back a string. It doesn't give you back a number. It was a little different in Python 2, but in Python 3, input gives you a string. So quote 0 quote, which is what we typed here. We didn't type the quotes, it's a string.
Wait, why is input? Hold on. You said input gives you a number or an integer? What do you say?
Here we go. Program starts. We do the input, side effect. It prints out this and then waits. We type in 0. That comes back here. And the 0, which is a string. Input gives you back a string. It doesn't give you back a number. It was a little different in Python 2, but in Python 3, input gives you a string. So quote 0 quote, which is what we typed here. We didn't type the quotes, it's a string. Gets stored in the imp variable. Then we move to the next statement. And on this right-hand side, we convert that string variable to an integer. So that becomes the integer 0. We add 1 to it, and then that becomes 1. And then we assign that into USF. I've named this variable United States floor, right? So imp is the input and USF. That's mnemonic. It doesn't know anything about elevators. It's just I picked a variable that was quite friendly. And so at this point, USF has the United States floor that's equivalent to the European floor. And then I just fall down and I do a print statement. Print out US floor, comma, that's this space right here, and then whatever the contents of the US floor variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European...
I think that's wrong. You said 4 and then 3.
Floor, US floor, comma, that's this space right here, and then whatever the contents of the US floor variable is. And you could see that I could write this on 4, and it would say 3. I could write this and say 7, and it would say 6. This is an amazing program. It converts floors in a European numbering scheme. Wait, actually no, I got that wrong.
Oh.
Hang on, let me clear this. I wasn't thinking clearly. I could type in 4 and it would give me back 5. I could type in 6 and it would give me back 7. See, I'm confused. Haven't been in Europe in a couple of months, and so I forgot all about the floors. But that's the idea. Now, this is a super, super, super simple program. Not super useful, but you get the idea that we're going to pull some data in. We're going to do some intelligent thing. Soon this will be hundreds of lines of code instead of one line of code. And then we're going to present the results to our user. Now, another element of most any programming language is what's called a comment. A comment is a way for you to put in a program file some text that's to be ignored by Python or C or whatever language we happen to be using.
We learned this.
In Python, comments start with a pound sign. So what you could do is put a pound sign anywhere in a line, and then after the pound sign, Python ignores everything after that pound sign. It can be the first character.
Sorry if you can hear me blowing my nose.
Recurring concept
wasn't really blowing it.
talk a lot about. We're not going to cover this.
Sorry.
Remember what this does. This is counting how many letters. There's 16 thes, and there's in that file there was 6 2s or whatever it was. This is that code. We'll get back to this code. But what we've done here is I've added some comments that are really for human consumption. So this first paragraph is get the name of the file and open it. The second paragraph is count the word frequency. Maybe I should have said histogram here. Count the word frequency and assemble a histogram. And then here I'm putting this pound sign in, find the most common word, and then I'm all done. I print the stuff out, right? And so all I'm saying is comments are for people to read. Your next programmer or the person who's going to change your program after you're done with it. And they're nice. And you don't have to use any particularly weird syntax or variable naming conventions. You put a pound sign in, and you can write anything you want from that point forward. Okay, so we've talked a little bit about variables and types and mnemonics and how we would choose variable names and how expressions work and the various operators, converting between different types, printing, input, output, and comments. So that just kind of gets us sentences. And coming up next, we'll talk about conditional execution, where we're really starting to move up to paragraphs. So see you in a bit.
Cool. Excellent. So we'll do this. We'll move on to the next video, and then we'll tackle these. So we'll just kind of, and we'll leave, when we go to the next video, we'll leave this here for now. Coming down to it for this stream. Need more space. Here we go. All right. I'm going to replicate this width equals 15. Height equals 12.0. Print. I really need to know what those are called. I don't know what they're called. Height divided by 3. So because we're dividing it, it's going to come out as a float anyway. But I don't know. I don't think he mentioned it yet. Spoilers. But if you divide or multiply, if you deal with something that is a float, which in this case height is a float, the outcome will be a float. Not the other way around, where if it's like you deal with an integer and a float, the result would be an integer. In this case, it would be, as far in Python, if you're dealing with an integer and a float, outcome's going to be a float. So it's going to be, well, let's just see. 4.0. Spool up the FTL. I don't even know what that means. Okay. Moving right along. Conditional execution. How are we doing? Whoops. Whoops. Conditional execution. We're about halfway to where I was before. We're making good time. All right, first exercise.
Oh, welcome to Python for Everybody. I'm Charles Severance, your instructor. And in this assignment, in this video, I want to work through exercise 2.2. And it's just a basic hello.
I don't know what 1. You said 2.2. I don't know what the other ones were. So.
Kind of hello world. And so I'm going to show you how I want you to do these things. And I've got this folder called Python for Everybody. And I'm going to use the Atom text editor.
We're going to use
the whole thing is supposed to say, hello, enter your name. There's the last one we did. Okay, so I'm going to make in Python for Everybody, I'm going to make a new folder.
Okay, so I'm going to minimize this. This is my coding folder that I have on my desktop. I have it on my desktop just so it's easy to see. I'm going to delete all this. Just so I know, just so we can kind of start fresh, right? And I want to make a new folder actually, and I'm going to coding projects. Nope. I don't know why this does this, but my computer lags like crazy when I make new folders. I don't know why. Come on. There we go. Okay.
New folder. And I'm going to say EX0202.
I'm not going to do it exactly like him.
Exercise. And I'm going to create a new file. And I'm going to say print hello. And I'm going to say file, save as. And it's important to get these in the right folder. And so I'm going to call this ex02.py. Always end these in Python because then you get the syntax highlighting. Okay, so now, again, you're not going to like this, but I want you to learn to execute these things using the real tools that we're going to really use. Because when you're applying this, I want you to know how to actually do real work. So I need to get to the point where this terminal program, and I could say start run terminal. That's another way to get the terminal program started, but I've got her down here in my docs, so
We're gonna do this too.
that saves me some time. And of course,
For
if you're
now,
on
at
Windows,
least.
this is the command prompt.
Yep.
And so
Windows,
in Windows
baby.
you type CD, but in Mac I type PWD, and that shows where I am at in the directory structure. And I can go into my desktop. This would work the same. And I can do an ls. In Windows I would say dir. And I see that this.
Wait, I'm sorry, what?
Go into my desktop. This would work the same. And I can do an ls. In Windows I would say dir.
Oh, okay, so dir for directory. Okay, so we're in Windows, right? So cd dir. Dir. Okay, so this is telling us what's all on the desktop. Coding projects. So, what he's going to have us do...
And I see that
we're just going to get into the folder that we made.
Desktop folder. And
so we're gonna do this here. Let's close out all this. What? Don't save. Out of that. New file. And exercise. We'll call it 1. Coding. I can't remember if it... I feel like I'm doing something wrong. Text file? Okay. Select a language or fill. Select a language. Okay, here we go. I think this is what we want. Now we're going to save as... Okay, this is what we want. X1. And replace.
And I'm going to go into PY4E. And if I keep doing
we don't have
PWD,
PY4E.
I'm navigating deeper and deeper into this directory structure. And then I do an ls here. And I'm going to CD one more time. And if to a...
So we're going to go change directory. That's what CD's for. And go to coding. Now we're in coding. And now we're going to go to dir and see. There's exercise 1. Right?
Folder. Oh, I did that really quick and didn't tell you what I was doing. CD EX tab. So that's because if the name of the file or...
So that's helpful too. So we can go to... Wait, why do we need to go CD? I mean, we're already in there. I don't think we need a CD.
Folder is unique. You can hit the tab in the command line and away we go. And so now we're in this folder, in the users folder, Py4E, desktop.
Does PWD work here? No. dir is what we have. Yep.
Py4E EX0202. And then if I say ls, and that's what you want to get to. You want to get to where you know where you're at in the folder.
What does ls do? We don't have ls.
Folder structure, and you know the file that you're going to run. For each file or folder is unique, you can restructure, and then I do an ls here, and I'm going to, and I see that, and so
I want to see what
Windows, you type
ls.
CD, but in Mac I type PWD, and that shows where I am at in the directory structure, and I can go into my desktop. This would work the same, and I can do an ls. In Windows I would say dir. And I see this
dir is for ls.
Desktop folder.
Okay.
Folder. In the users folder, Py4E, desktop, Py4E, EX0202. And then if I say ls, And that's what you want to get to. You want to get to where you know where you're at in the folder structure and you know the file that you're going to run. And I've saved this, and so if I say Python 3.
Okay, so let's just mess around. Do what he did. Print. I like the two air quotes. Right? So, quickly, we can just straight run our code in our program. We can just run our code in Visual Studio Code, but he wants us to run it in terminal, or command prompt, which isn't a bad thing. So we'll do it. I can't say we'll be doing it forever, but we'll try it for now. So what we'll do, we're encoding, right? EX_1 dot py. Theoretically, when we hit enter, holy crap, I'm sorry. There we go. Is that a little better? There we go. Sorry about that. Theoretically, when we hit enter right here, it should say hello world. No. It's Python 3. That's what I have to do. EX1 dot Python 3. No. Hold on. 1. Is it Python 3 afterwards? Hold on. Let's just watch.
EX02.py.
It is py.
It runs. And now I know .py, and you know the file that you're going to run. And I've saved this, and so if I say Python 3 EX02.py.
Oh, so I have to, hold on. Python 3 EX. Did I save it right? I didn't save it. Hold on. Let's try this. Python 3. Okay, so that worked without the PY. I didn't save it as the PY. Frankly, I don't know that we need to save it as PY because we're using the Visual Studio Code. But hey, that works. We'll do it again. Python 3 hello world. Perfect.
It runs. And now I know that what I'm doing in this screen can be run in this screen. And oh, I did that again. I hit the up arrow and I can run it again. Cool. So you'll find that the way you write these programs is you write them here and then write them here and run them here. And again, there are shortcuts and those are crutches and you might like them, but I just want you to learn how to use your computer like a real person uses the computer, because that's when we start dealing with databases and files, you're going to want to know where you're at on your computer. And so if there's some fancy clicky button thing that says automatically run Python, that's convenient, but I want you to know all this stuff. Okay, enough about, well, probably I'll just keep talking about that all the time. So now that we've got our problem, write a program that uses input to prompt for their username and welcomes them.
Enter your name, Chuck. Hello, Chuck.
So this is pretty simple. Go back to Adam. Come on, Adam. Okay. So we have to have a variable.
Hold on. You just send a message real quick. This person just messaged me that I haven't heard from in a long time. Hold on a second. It's all right.
NZ.
Okay, so let's try and figure this out before he shows us how to do it. Can't say I'll always take this approach, by the way, but this would be good. Let's just save this as exercise 1, and we'll do save. Get rid of this, and we'll save this. What we're about to do is exercise 2. Right? Okay. Enter name, Chuck. Hello, Chuck. So name equals input. Enter. Wait. Enter your name. Space. Because the comma is a space, right? Print equals. No, print, not equals. Hello. Name. We'll save this as 2. You know, it shouldn't be plain text. It should be Java. Java. Python. Python. So in here, I wonder if, can I just do this now? No, I have to do Python. I just got a message. I'll respond later. ex2 y. Why? Didn't I say? Can it be like a text? What was it before? TypeScript? Before. I feel like I shouldn't have changed it to Python. Hold on, let me try this. ex2.py. What's this? It's like opening it. It wants to. That's not what I'm like looking for, fam. Oh, okay. So hold on. So it should just be text. I did screw up. TypeScript? I don't know what that did. No, that can't be. I feel like I screwed up. Let me just, hold on. Let me kind of forget this. Let me copy this, actually. Ooh. I'm going to get rid of this. I'm going to go in here. I'm going to get rid of this too. We're going to go in. One big Python. And we're just going to copy all that. Whoops. Okay. Now let's try this. Python 3, EX. What's EX1? It's just like a file? So, new text file. Can I just... Plain text. Text document, that's not it either. What the heck, man? Let me just... No such file or directory. Why? So I don't get why it's just like a file. Why it just says file? About this? What about this? Crap. What does this guy do?
Come on, Adam. Okay, so we have to have a variable.
Okay, before we do this, let's just see that it works in Visual Studio, because it should, right? What? Got a syntax. Perhaps forgot a comma. Enter your name. Parentheses, fam. Maybe that was the issue the whole time. That has to be it. That has to be it. Python 3. Nope. Wait. Okay, so it works. Oh, but we got the comma in here. Hold on. So we don't need the... But we need the comma. Wait. Hello. Okay. Right. Enter name. No. Hello name, because it actually is. Okay. Name. That'll do it. What? What do you mean I forgot? Hello. This can't be. Whoops. Hello, name. It's not. This is humbling. Thought we got this. One second. Quick break. So the parentheses can't be over name because we don't want it to print the name. Like print name. Yes. Boom. We did it.
NZT. Later we'll talk about choosing variable names. Right now I'm going to choose a crazy variable name. Input is a function, and then you put a prompt. And that's supposed to be enter your name, colon. I don't want to put a space in.
Did we get the colon in there? Yeah, we did.
So I'm going to save that and just run it for yucks. And there you go. That's one thing you'll get used to, is just typing gibberish really quick. And then we're going to say print. What do we got to say here?
Sorry,
print.
I got a message again. Oh, interesting. This guy messaged me from like 2 years ago. Like, you saw an old message from me. The old message was from like 5 years ago, man.
Hello. And go pull that variable back out. Save that. Command S is how I'm saying that. Save. Command S. I saved it. So I didn't make file save, but I could have said file save, but Command S saves it. And now I can run it again.
Wait, so it was .py for him? So let's try this. Python 3 ex2 .py. Oh my word. Okay. Correct.
Zap. Hello, Zap. now I can run my thing. Oh, and Command K clears it. I don't remember what it is on Windows, but there's a way to clear your screen.
I think it's
I like
CLS.
to keep my screens clean.
Yep.
Hello, Chuck. And so we have completed exercise 2.2 with a little program. Oh, and by the way, I'm using Alt-Tab. That's what when you see this, I'm using the Alt Command Tab, and the same thing works on Windows as Alt-Tab. Okay? Okay, so I hope that was helpful to you, just to kind of walk through one of the assignments, assignment 2.2 in Python for Everybody.
Boom. Done. That felt good. Moving on to this is the last thing. We're done after this, everybody. Done after this. I don't even know who's all. Let me check the stream. Okay. All right. Final stretch, home stretch, if you will. Let's do this.
Hello and welcome to Python for Everybody. My name is Charles Severance. In this short video, I will be explaining how to run exercise 2.3, where we prompt for some hours, prompt for some rate, and multiply them together and print them out with a little pay message. And so this is 2.3. Some of you will immediately want to go to the autograder and sort of do your homework on the autograder. I really would rather you didn't do that. Unless, of course, you're doing this on an iPad or an Android or something where you can't install Python. But you have to realize that the autograder isn't forever. You can only go so far with the autograder, and eventually you have to write a real Python program. So I'll eventually show you how to run this autograder, but I'm going to instead show you how to run it in the terminal. So I'm first going to go into my Python for Everybody folder, and I'm going to make a new folder. Command-Shift-N is what I just did there. EX02.
I don't know why it makes new folders.
Exercise 3. And so there's exercise 3. And I'm also going to go into Atom, which is my text editor. And see, I have that folder. And so I'm going to make a new file. And I always say print, I'll just say py for E. Oops. Py for E. And
we don't need to do this.
File save as. And I want to make sure it's in here. And it's going to be EX_02. I don't like putting spaces in file names. Some operating systems can handle them, but that's why I'm using underscores here. So I would avoid using spaces in file names. So as soon as I give that a py4e, as soon as I give it a Python suffix, I'm there. And so it shows up there in my desktop. And now I'm going to run the terminal program so that I can get there. So cd desktop, cd Python for Everybody. That's the folder on my desktop. And if I do an ls, I see a couple folders in a file. I can say ls-l and see a little more detail that these are these two are folders, and this one's a file. So change directory, cd ex0203. And so now I'm in that folder. And if I do an ls-l, I see that file. I can also do an ls.
What the heck minus L?
That folder. And if I do an ls-l, so change directory, cd ex0203. And so now I'm in that folder. And if I do an ls-l, I see that file. I can also do an ls without the -l and see the file. And now I say Python 3.
See, why would
these two goes up there in my get there.
I'm sorry.
So cd desktop.
I know.
cd Python for Everybody. That's
like, I know we're not messing with it. Like, we're not doing all this, but it's like, I'm curious.
That's the folder on my desktop. And if I do an ls, I see a couple folders in a file. I can say ls-l and see a little more detail that these are these two are folders, and this one's a file.
Wait,
so change directory our file. I can say ls-l and See a little more detail that these are these two are folders, and this one's a file. So change directory, cdex 0203.
Okay.
And so now I'm in that folder. And if I do an ls-l, I see that file. I can also do an ls without the -l and see the file.
Sorry for the messages.
And now I say Python 3 ex0203.py, and it runs. And you'll see me, no matter how many times you watch me, you'll see the first thing that I do is get to the point where I know I'm in the right directory and I can run a little hello program. Before I start coding, I just don't like being crazy, right? So now I'm going to go back and take a look at my assignment. Enter hours, you got a prompt for hours, ask for a number, enter rate, prompt for rate, and then
okay,
calculate pay.
So they should be easy. Let's try and do this before. Clear. Okay, so okay, H for hours equals input enter hours, right? Then wait. Input hours, right? Hold on. Then what we're going to do is turn input hours. Wait, hold on. Output hours equals integer IH, right? Because inputting it's a string. So we're turning it into an integer. We'll shove it down a little bit. Input rate equals input enter rate. I hope I'm not screwing this up. Okay. Okay, so right now we have it where you can put in something for or the hours, and that turns the, and then we need output rate int input rate. Now's the easy part. Pay equals output rate times output hours. Then we simply print pay. That feels good. So we're gonna save this as exercise 3. We're already encoding Python 3. It's a pain to write that crud out. That's why I don't like doing this in the command prompt. But maybe I just have to suck it up. What's going on? Enter hours. That's what you have a problem with? Is it printed? Not have to do this? I don't have to do this. Fam. Okay, let's do something easy. Enter hours, 10 hours. Okay. So once I put in 10, right? Like 10 times 10, it's 100. So pay should be 100. Yes! Yes! Software engineer, folks. We're on the way.
So there's a couple of input statements here. XH is my variable I'm going to choose. Later,
We already
I'll
know
choose
this. We're just
more
watching them.
effective variables, but for now I'm going to make them silly. Enter hours, space. And then I'm going to copy and paste and call this XR for rate.
I like how we did it more.
When you're doing this, you need to be very careful to, and so now I'm going to calculate XP time, which is XH times XR, and then I'm going to say print.
He did it way quicker than us, though.
Okay. I don't need to put a space because this comma effectively creates a space.
Did I do that?
And then I'm going to save that.
Oh, technically I didn't have the comma, the colon
my
in there.
terminal program. Clear my screen in my terminal program.
Wait. Wait, okay, so technically it did what I wanted it to do. Let's do something else. Print, pay, comma, pay. So that, save it. The heck, man. I hit tab trying to save some time that didn't work for me. Shoot, man. Whatever. Okay. 10. Now we should get pay, 100. Why no colon? Oh, because I'm an idiot. That's why. A.
And I'm going to type up arrow because I already typed Python 3x203.py. So my hours, I'll just start with something really simple that I can calculate in my head. 10 and 5. Whoops. Can't multiply sequence of by sequence of non-int of type stir. Here we have a traceback. And again, I encourage you to realize that
he didn't turn them into
these tracebacks
integers.
are not, personal attacks by Python on you, even though they might be frustrating. And so the way to parse this is start by saying line 3. Something's wrong at line 3. It's pretty good at knowing what line it is, or it's either that line or the line above it. And it's something about multiplying. You know, what it's really saying is I'm confused. I have to stop because I cannot understand your instructions. So the problem here, of course, is that this is of type string. And so you can't multiply a string times a string. Okay, and so we can convert this using the float. So that's a function call now. We're passing the string xh in, and the value we get back is the floating point version of that. And then we call float for this as well.
So technically we did it differently.
Save that.
Technically we did it differently. We turned it into integers.
always remember to save. So I'm going to run it, and so I'm going to run my hours of 10 and my rate of 10. And it's 100. And so that looks pretty good.
So you got the float though.
So let's go ahead and try to run this in the autograder. And this is my idea is you'll take this and you'll copy it, and you'll go back to the autograder now and just paste this in. Okay? And so it says use 35 hours and a rate of 275.
We're not messing with this.
So let's check the code.
We're
35
done.
35 hours. Okay. 75. Oh, no, 275. 2.75. And so it's running, and it's running, and it's running, and it works. And of course, now I've got my grade. So this idea where you work here to get your assignment done correctly, and then you run it in the autograder, is the way I intend for you to do it. But again, if you can't do it that way, it's a great way to get started to just write your code in the autograder. And, you know, you can change your code in the autograder and then run it again. Of course, this is going to fail. 35 and 2.75. And of course, you get a mismatch, and now it's angry at you. And the mismatch here, of course, is because I print howdy pay and pay. And it's real picky about it. And you think, oh, I got the 96.25 right. Well, it doesn't really care so much about that. So let me go ahead and fix this and run it so we leave on a successful note. 35 hours and 2.75 as the rate per hour. It's kind of a low rate per hour. And we're getting successful. And of course, that means that you now have a grade on assignment 2.3. Look at that. I got a grade on assignment 2.3. Unless, of course, you're running this in some other environment. Okay? Thank you so much, and I hope that this has been useful to you.
Awesome. Okay, done with that. Clear this out. Save this just to be sure. We'll clear this as well. Oh, does it just... Wait, what does this even do? I don't know. And we'll clear this for the next time. Okay. That will do it. Thank you guys. So, hold on. Let's go to the... There we go. Thank you guys so much for sticking with me. Sorry we lost connection there. Midway through. But thank you for sticking with me. This is a bit of a longer one, the longest stream that I've had. I mean, if you don't include like the splitting, I think maybe even splitting up the, well, no, if you don't include, it's probably the, like, without the interruption, this is the longest stream that I've done. Thank you guys for watching. We had some good stuff happening. I mean, technically I've done this stuff before, but it's kind of like it's like I didn't approach things this way the first time. Like I didn't try and tackle everything before he did it for me. I just kind of followed along with him, which we might do sometimes. But I feel like I'm learning it better this way, this time. And so I hope that it's not a matter of, I don't know that it's a matter of me going through this a second time. Because like I showed you guys, we're already about halfway to catching up to where I was before. So it's not like I did all that much. But I feel good about how this is going. We're on day 2. So thank you guys so much for watching. Please hit that like button, hit subscribe if you want to, and thank you guys for stopping by. And I will see you guys tomorrow when what are we getting into tomorrow? Conditional executions. All right. You guys have a great day.